Okay, so for passage 4, we're going to take a look at this one. Just like with the other science passages, a key thing to remember is you don't want to spend a ton of time trying to read through everything and understand everything. They're going to make it confusing. They're going to make you look back at the passages anyways. They're going to ask you very specific questions. So typically what you want to do is look at the intro part that they've got here and continue on from there. So let's move this. It says figure 1 is a diagram of an RLC circuit. The circuit has a power supply and 3 components: a resistor, R, an inductor, L, and a capacitor, C. So we're looking at electricity in this one. And that's good. So let's jump straight into the questions now. This first one says, according to figure 2, the maximum positive value of Vs was approximately what? So let's take a look at figure 2 here. Let's go ahead and read the intro paragraph at this point. It says electric current can flow through the circuit either clockwise, a positive current, or counterclockwise, a negative current. Figure 2 shows how the electric current in the circuit, I in amperes, A, and the power supply voltage, Vs, in volts, change during a 20 millisecond time interval. So this one, all it wants to know though, what is the maximum positive value of V sub S, which V sub S is this lovely dotted line. And so we just come right here and we say, okay, well, there's the maximum value, which for V, we're looking at this side, which has volts, not this side, which has amps. And we come across here, that's about 250, so C is going to be our answer. 250 volts. 22, a period is the time required for a wave to complete one full cycle. So starting right here, right, that would be one period to do one full wave wiggle. Based on figure 3, the period for V sub L was what? So let's come up here. Let's look at VL, which is the medium dash guy right here. And it looks like it does one cycle over the course of this whole graph, where it starts at the top, goes down, and comes back up. And this says down here we've got time, which is 20 full milliseconds. So we can come down. H, it takes 20 milliseconds. Oh, geez. To do that. Right there. Okay, so jumping down to 23, according to figures 2 and 3, which voltage varied the least during the 20 millisecond interval? Okay, so we've got V sub S, R, L, and C. So V sub S is on figure 2 here, which has quite a variability. It goes from about negative 250 to positive 250. Looking at this guy here, looks like the one that varies the least is the dotted medium one, the hash, I guess, which is V sub L. So let's come down here. V sub L varies the least. Okay, 24. Polarity refers to whether a voltage is positive or negative. A voltage of 0 volts has no polarity and can be ignored. Based on figures 2 and 3, which two voltages were always opposite in polarity? Ooh, okay. So we're just looking for one where when one is positive, the other is negative. Let's clean this up a little bit. And right away, one thing I'm noticing is that these two lines right here actually cross. So this guy right here, the V sub L, goes down and then up. And this V sub C is the opposite. Okay, so you can see when this one's positive, that one's negative. Those are inverse. We can also double check. So those are flipping right at the 7 and 15 second mark. We can also check. It did tell us to reference figure 2 here. This guy, though, V sub S is switching at the 3 and 13 mark. So that also doesn't quite line up. So we'll say that that was VL and VC. Those are the two that are alternating. Which one is positive and negative, having opposite polarity. 25 says, based on figure 2, at which of the following times was the current in the circuit flowing counterclockwise? Okay, so let's clean this up a little bit. So counterclockwise, we can come up here. It tells us that there's a negative current when it's flowing counterclockwise. So the current is this solid I line, so we can see we've got our negative current, meaning it's counterclockwise between time 10 and time 20 milliseconds. So we can come down here. Oh, now 10, remember, is at 0, so that one won't count as a negative or counterclockwise one. So our answer is just going to be D. Okay, 26. The table below lists the electric charge in microcoulombs, which is that right here. That's a micro, fun fact. Stored on the capacitor at 3 times during a 20-second interval. So at 7, it's 0.51. 7 milliseconds. Then it goes up to 0.87. And it's going back down to 0.51 at 13. So this is based on figures 2 and 3 from time 7 milliseconds through 13. Did the charge on the capacitor more likely change in sync with I or with VC? So let's look. So we're looking at time 7 to 13. We want a graph that looks like this. It's going up and then back down. And we're just looking at I and V sub C. So I, we can see, let's look between time 7 and time 13. All I is doing is going down. That's not quite right. Let's come look at V sub C over here. So between time 7, it's about right there, and time 13, we can see, there we go. So that matches up with what we saw with this little chart right here, that it goes up and then back down. So it's going to match V sub C, so it's one of these two, and it's going to be J, because over that time interval, both the charge and the V sub C increased and then decreased.